Hello guys, good morning. And today's GFG problem is insertion short for single linked list here. And you're given a single linked list, sort the list in ascending order using insertion sort here. Using insertion sort algorithm. Okay. Now, uh, given a string list here, linked list here. Given a linked list. Okay. And we need to transform this linked list into a sorted list. That means we have to sort the linked list in ascending order here. Okay. So using insertion sort here. Okay. Okay. For sorting this using insertion sort, now I will be using a node answer node here. Node answer equal to null. So initially I will initialize that answer node to equal to null, and I will traverse over this. I will traverse over this linked list, given linked list. I will insert each node of linked list in that answer such that the node is such that okay. Now I will clarify this question, and now I will traverse over this linked list like one node after one node. I will traverse over this linked list. On every node, I will call a certain function which will insert the node in answer such that the answer node is sorted in nature. Okay. So I will so first step is I will traverse over the given linked list, right? And while traversing over the linked list, on every node I will call a certain function where the functionality is to insert the given node into the answer list so that such that the answer list is sorted in nature. Okay. So first step what we have to do is we have to traverse over the linked list, right? So in order to not change the head nature, I'm using a temp variable here. Okay. Node temp equal to null equal to head. I will initialize my temp variable equal to head here, and I will traverse over the head here. Okay. While temp not equal to null, while temp not equal to null, so I will first of all I will for further iterations I will store the next pointer of temp variable in next variable, right? Temp dot next, so that I don't lose the track of next node track, right? So in order to not lose the next pointer, like next nodes in the linked list, we need to first store the next nodes in a particular variable, and we have to perform the operation on that given node. Okay. So I will call a function which is insert in answer. Okay. I will call this function and I will pass the temp variable here. Okay. I will pass the temp variable. I will call the function here. It will public static um, void insert and answer, and it will take a variable temp. Okay, this function is to what, what is the functionality of this function? This function is to insert the node into the answer, okay, such that the answer is in sorted nature. Okay, so for that we have to take some edge cases here. Okay, so initially the answer can be null, right? Okay, initially the answer can be null, so we have to take care of that in edge case here. Answer, if answer equal to null, then we can directly insert the node into the answer, right? That's right. Or another case. So we will first point out the edge cases here. Answer is null initial, okay, or else in ascending order, right? So in ascending order, the order of the nodes in the list should be the adjacent nodes should be, if a is an ab are the adjacent nodes, then a dot val is lesser than equal to b dot val, right? This should be condition, right? In adjacent so in the adjacent nodes of a linked list are sorted in ascending order. If they are sorted in ascending order, then this condition should satisfy for every two adjacent nodes, right? Right. So if they are if they are not sorted in nature, then the condition will be a dot val is greater than b dot val, right? Then if this condition fails, if this condition fails, then we can say that they are not sorted in nature, right? So for that, so for that, if answer dot val is greater than temp dot val, okay, this will be the condition. If first node, the first node only greater than the value of the temp, first if first node of answer only greater, if first node of answer only greater than the temp, then we can say that we can insert our temp variable in starting only, right? For these two conditions we need to, these are the edge cases. And another edge case is, and the like until some point there is an sorted order, and after that some point there is an unsorted order from the from wherever there is an unsorted order in the linked list, from there we need to, from there at, at that position we need to like at that position we need to insert the temp variable, right? Insert the temp node there, right? So for example, if the linked list is in this way, 2, 3, and 2, 1, if the linked list is in this way, right? So until here the linked list is sorted, right? And after that the linked list is not sorted, so we need to, wherever there is an unsorted part, there we need to insert our temp variable, and we need to do the remaining operation, right? And we need to attach this to our temp dot next variable, right? That's it. So these are the three edge cases we need to handle here. Okay, so we will write the pseudo code here. If answer is equal to null, or answer dot val is greater than temp dot val. Okay, okay. So if answer is equal to null, then if answer is equal to null, that means answer has no nodes at now, no nodes present. And if answer dot value is greater than temp node value, at first node only there is an unsorted part, so we need to insert the temp node at the first starting node, right? Okay, so now Now we will store temp dot next equal to, okay, inst now it's a best practice that we are whenever we are whenever we, whenever we want to modify the existing existing list, it's better to store the list in another variable and modify that way, and modify that modify that variable so that it will not disturb the original uh, original list here. It will not disturb the original list here. So in order to not disturb the original list, we need to store that in separate variable, and we need to modify that separate variable here. Okay, this is the best practice and linked list here, so that we don't lose the data here. Okay, so temp dot next will be, so your car it will be, and it will be career if temp dot next, if car dot value is greater than or temp dot null. So we have to store the temp dot next equal to car here, and car equal to temp here. Okay, so basically what I'm saying is, if something if we will try to do this in a dry run here. Like, first of all, we will solve this problem. Like, first edge case and second edge case are done here, and we need to handle the another edge case where there is an unsorted part, right? So for this, we need to move to a certain point where there is an unsorted part. Okay, so while cur dot next not equal to null, and cur dot next dot val is lesser than or equal to temp dot val, we need to move to a certain point cur equal to cur dot next. We need to iterate our current point to that point where there is an unsorted part, right? Unsorted part. So now we are at an unsorted part, right? So after this iteration, we will be at an unsorted part, right? So now temp dot next it will be equal to current dot next. Same as this above conditions only. We need to uh, we need to pass the we need to store the current dot next to the we need to store the current dot next in the temp dot next variable. temp, we need to add current dot next data to the temp dot next data, and we need to we need to save the data in current dot next equal to temp data. We need to attach the current dot next data to temp data, so that in this way we can sort this array, sort the list. So after this, after the insert in answer variable is done, then we need to write this condition, right? And at last we will be uh, head equal to answer, and we will be returning answer here, head here. Okay, this is the solution here, and now we will do the dry run here. Okay, so initially the answer is equal to null, right? And now temp is equal to head. Now temp is here, so temp is not equal to null. Okay, so node next will be, and next node equal to temp dot next, that is from 23. Okay, from 23 the next node will be there, and the temp will be temp equal to 30 here. Okay, now temp is equal to 30. Now we have to perform the insert in answer. Okay, so node cur here, cur equal to answer. Okay, that is null here. Okay, if cur equal to null, yes, cur is equal to null, right? So what we have to do? So what we have to do? So 30 dot next, temp dot next. So 30 dot next. So here, so what we have to do here? So temp dot next will be equal to cur here. Okay, so 30 will be equal 30 dot next. The next variable will be equal to null here, and we have to match the current variable. So now current will become temp here. Okay, okay, this thing will be here. Okay, now answer is equal to this. Now answer is equal to answer is now in this way, and now we have to move to the next pointer, right? So now it will be 23, and next will be 28. So current will be currently pointing to answer, right? That is 30 is not equal to null. Okay, so is current is not equal to null? Is current is equal to null? No, right? Is current dot value is greater than temp dot value? Yes, right? So 30 is greater than, so 30 is greater than, so 30 is greater than 23, right? So we need to change the, so we need to change the, so we need to perform this operation here. So temp dot next, what will be the temp dot next? 23 dot next will be current, that is this thing, right? This thing, right? And curve will become this thing, right? Okay, now it is sorted, right? Now answer will become this thing. Okay, so now temp will become 28, and next will become 30 here. Okay, now we have to call this insertion function here. Now if current is equal to null, no, right? Current is not equal to null. Current dot value is greater than, is current dot value is greater than temp dot value. Temp is 28 and current dot value is 23 here initially, right? So current is equal here, and current dot value is 23 and temp dot value is 28. It is not greater, right? So this condition will form, will fail, and we will be coming to this condition. Now we have to go to a position where there is an unsorted bar. Now here the current value is, and temp value is this thing. If current dot next is not equal to null, is current dot next not equal to null? No, right? It is present, right? So, and current dot next, is current dot next is lesser than or equal to, right, temp dot value? No, right? No, right? Current dot next is this thing. So this value is 30. 30 is lesser than or equal to temp dot value 28. No, right? So this condition also fails now, and now we need to perform this operation. Okay, so temp dot next, what will be the temp? 28 dot next will become cur dot next. Cur dot next is this thing, right? So, and cur dot next, current dot next is current. to dot next. Current is this thing. So 23 dot next is equal to this thing, right? So in this way we can solve this. Hurry here. Okay. Now temp will be equal to 30 and 30, and the next will point to 11 here. Okay. Now this is an interesting test case here. We will be doing this only this thing the last time, and this is for this node we'll be doing this thing. And okay, so is now we'll perform the operation. Current is equal to null. Is current is equal to null? No. Current dot value is greater than temp dot value. Is 23 is greater than 30? No, right? This condition will become false and will fall into this case. Now current is in this way and temp dot value is this thing. Is current dot next is equal to null? Not equal to null. Yes, it is not equal to null. And current dot next dot value is lesser than or equal to 30. Is 28 is lesser than or equal to 30? Yes, it is. 28 is lesser than or equal to 30. So I will move my current to here. Now current will become 28. Yeah, okay. Now current will become 28 here. So current equal to current dot next. Here will be current here. Okay. Is current dot next not equal to null? Yes, current dot next is not equal to null, right? And current dot next dot val 30 is lesser than or equal to 30. Yes, it is true, right? So now we need to move our current here. Okay. Now current will become 30. So current dot next is not equal to null. Current dot next is equal to null. So we will from this we will here the condition will fail and we will move here. So now temp what is temp? 30, right? 30 dot next will be current dot next. Current is equal initially current is here, right? So current dot next is null, right? Okay. Now current dot next 30 dot next is equal to temp, which is temp here. Temp is here. Okay. Now wherever the current is, we need to do the thing here. Okay. Is this sorted here? In this way we need to do the sorting here. So when we perform this operation, so this way we need to perform this operation here. Okay. Initially we will take a global variable static node answer here, and okay, now head is equals to answer, and this thing should be passed as an function here. Okay. Now yeah, that's it. So now this is done. When we run this, so here there is no val here, so it is not val, it is data here. Data here, data, and here it is data, and here it is also data here. And now we are good to go. We'll compile this. Okay, we are done. So now we got the same list, right? 7, 11, 14, 11, 14, right? So we need to, when we submit this, Okay, solving the sum. I'm not getting this. Okay, node car is equal to answer, and okay, lesser than equal to, and the temp dot next equal to current dot next equal to. Okay, this is correct, right? So why am I not getting this? This output also is also correct, right? Return head only here. Okay, now okay. We are not initializing our value to. That's why we are getting here. We are not initializing our node answer equal to node answer here. So that's why we are getting this thing. Why? So when I view this answer equal to null, okay. So this is the same code, right? Okay, I think I'm doing something here. I think I'm doing something here. I'll just do one thing here. Now temp, no. Temp not answer, and we are just comparing the single character, right? So we don't need to do this thing. Don't. Now here we need to. Oh, sorry. Node cur equal to answer. Yeah, I think now it will be cannot find. Okay, now this will become answer. Okay, now it is passing. Okay, thank you. This is the solution. If you have any doubts here, you can just comment below and I will be answering your doubts.